Welcome to part three of lesson three, History of Economic Thought. In this lesson, we're going to look at Anne Robert Jacques Turgot and his economics, which were way ahead of his time. Turgot was born on May 10th, 1727, in Paris, France, into a distinguished Norman family with a tradition of public service. His father served as the provost of the merchants of Paris. Educated at the Sorbonne, Turgot was initially prepared for a clerical career, delivering Latin dissertations on Christianity and the progress of the human mind. In 1750, he chose not to take holy orders, saying he could not bear to wear a mask all his life. Turgot's public service began in 1752, where he pursued reforms including the abolition of the practice of forcing peasants to work on roads without pay, deregulation of the grain trade, reduction of guild privileges, and cuts to government spending. Intellectually, Turgot was shaped by Enlightenment thinkers, corresponding with Quesnay and other economists. His 1766 work, Reflections on the Formation and Distribution of Wealth, bridged physiocrats and classical economics, exploring wealth creation, commerce, money, and interest, and anticipating Adam Smith's The Wealth of Nations. Turgot emphasized land and agriculture as fundamental sources of wealth and argued that the shift from feudalism to capitalism was driven by capital accumulation, specialization, and trade. He anticipated key ideas such as diminishing marginal returns and the entrepreneur's role in development. Though his economic career was brief, his insights laid the groundwork for classical economics and influenced future economists. In this lesson, we're going to explore Turgot's economic theories. We will reimagine Turgot's groundbreaking contributions to economics, his insights into savings, capital accumulation, interest, and economic growth, using modern analytical tools he could never have imagined. You will bring his theories to life by entering the assumed parameter values for the model, provided in the table below, into the Excel worksheet embedded in this lesson. By leveraging Excel's calculation and graphing features, you will simulate the conversion of savings into capital, examine its impact on production, and visualize the growth dynamics Turgot anticipated centuries before the emergence of modern growth theory, computers, and analytical tools. Economic output is the variable Y, the real value of goods and services produced from combining capital, labor, and technology. We're going to use per capita economic output. Initial capital, K subscript 0, 409. It is the real value of tools, machines, buildings, or money used in production. For example, plows or ovens. The subscript 0 indicates that the capital value is the amount of capital in year 0 of the model. Labor, L, is 435. It is the workers who contribute their time and effort, for example, factory employees. Productivity, capital A, equals 0.09. It is how efficiently capital and labor create output. For example, a faster oven bakes more bread. Technology adoption rate, tau, it is assumed to be 3%. It is the rate at which knowledge grows, which enhances productivity. The depreciation rate, delta, is 5%, the percentage by which capital loses value each year due to obsolescence or wear and tear. Savings rate, S, is 10%, portion of income people save. For example, saving 13% of a paycheck. Time preference, rho, 0.04. The higher this value, the more people prefer consumption now rather than later. LF is loanable funds. Loanable funds demand slope, beta, is 0.001. It is the decline in the interest rate when loanable funds demanded rises by 1 livre. Loanable funds demand intercept, I subscript 0, equals 0.085. It is the interest rate borrowers are willing to pay when loanable funds are most scarce. Subscript 0 corresponds to zero investment. This is the Excel model I mentioned that was embedded in this problem. I've downloaded this spreadsheet by clicking this button, and then I've opened it over here. After entering the assumed values into the worksheet above, follow the instructions below to manipulate it. The calculations are automatically performed in the trend table, cells J7 to P29. J7 to P29. In Reflections on the Formation and Distribution of Wealth, Turgot explained that adding more labor to fixed amounts of land and capital yields progressively smaller increases in output, a principle now known as the law of diminishing marginal productivity. Experienced manufacturers of his time likely understood this intuitively. For example, adding a worker to a factory with only a few employees can boost output, but adding another worker to a factory already crowded and running at full capacity yields only a small gain, or maybe no gain. This occurs because machinery, equipment, buildings, and tools remain fixed in the short run of the day or week, while labor can be adjusted at any time. When resources are underutilized, additional workers significantly increase output. When they are fully utilized, extra workers add little. He likely drew inspiration for this principle from observing situations. The law of diminishing marginal productivity applies to any input to production. For capital, the marginal product of capital, MPK, is the increase in output from adding 1 unit of capital, holding all else constant. Its values are in cells N9 to N29. Marginal product to capital values are in cells N9 down to N29 in the trends table. When all inputs except labor are fixed, adding 1 unit of labor increases output. This increase is called the marginal product of what? I'll let you figure that one out. To see how the marginal product of an input declines as its use rises, holding all other factors constant, change the values of labor in cells B3 to compute year zero economic output for various labor values, holding capital constant at 409. So I'm going to first set my values up here. First, I need to set initial capital equal to 409. Labor needs to be set equal to 435. Productivity is 0.090. Tech adoption rate, 3%. Depreciation rate, 5%. Savings rate is 10%. In order to change it, I have to change this. And I'll change this. So we're going to change the savings rate in this problem and see how the economy responds to it. Time preference is 0.04. Loanable funds demand slope is 0.001. Loanable funds demand intercept is 0.085. So we're going to change the values of labor in cell B3, which is right there, while holding capital constant at 409, which I've already set. With 409 and 435 already in cells B2 and B3, type 435 in cell J2. This is cell J2, and we're talking about labor here, so I'm going to type 435 into here, and then I'm going to type 409 into K2, because that's what initial capital is. The value of economic output for this combination of labor and capital in year zero is 120.046. So right-click, paste those values. If it and the value in cell M9 of the trends table are the same, type it into cell L2, which I've already done. If this and that are not equal, one of these values over here must be incorrect. So just double check that. This value and that value are identical, so I'm going to proceed. Next, increase the value of labor in cell B3 by 1 unit to 436. So I'm going to increase this to 436. Then I'm going to type 436 here because I'm increasing labor by 1 unit. I'm holding capital constant, so I'm going to type that as 409. And then the output in year zero with labor 436, capital 409, output is 120.184 livres per French subject. Then I'm going to take the difference in the labor force values, which is 1. I'm going to calculate the difference in the output values. And the marginal product of labor is the difference in output or the change in output for that 1 unit change in labor. And it's 0.138. 435 units of labor and 49 units of capital produce what? They produce 120.046 livre per French subject. 436 units of labor and 49 units of capital produce 120.184 livre per French subject. This is the uncrowded factory situation because in the next scenarios, we're going to increase the labor to 1,211 and 1,212. So this is the uncrowded factory situation. And for it, we're going to calculate the increase in labor. I've already done this, J3 minus J2 in cell M3, and increase in output by typing L3 minus L2 and cell N2. We've already done both of those here and here. And we took the ratio of those two differences right here, N3 divided by M3. Adding 1 unit of labor increased output by how much? 0.138. Now we're going to go to the crowded factory situation. In year zero, change the labor value in B3 to 1,211. 1,211. I'm going to type that over here. And then I'm going to type 409 because we're holding capital constant. I'm going to come down here and get the economic output per French subject. I right clicked on it, copy. I'm going to right click paste values. And then I'm going to enter it right here as well. 200.298 livre per French subject. Then I'm going to increase units of labor to 1,212. I'll do that right here, 1,212. I'm going to type that here again, 1,212. The capital has not changed, 409. The output has increased to 200.381 livre per French subject. I'm going to calculate the difference in labor from 1,211 to 1,212, and that difference is going to be 1. I'm going to calculate the difference in output, 200.298 to 200.381. Increase in output you get when the factories are crowded is smaller than the increase in output when you increase labor by 1 unit when the factories are uncrowded. Then we got to take the ratio of the two, which is just 0.083. 1,212 units of labor and 409 units of capital produce 200.381 livre per French subject. Adding 1 unit of labor when the factory is crowded increased output by 0.083 livre. The marginal product of labor was 0.138 when the factory was uncrowded. The increase in output is only 0.083 livre when the factory is crowded, when we have a lot more labor in the factory. Marginal product of labor decreasing from 0.138 when the factory was uncrowded to 0.083 when the factory was crowded illustrates, and I'll let you figure this answer out. Now, picture Turgot beaming with pride at your discovery, marveling at how you grasp in moments what took him years of deep contemplation to deduce, given the limited knowledge and absence of modern tools in his time. Imagine Turgot in 1770, painstakingly collecting economic data in his official duties for the government. For this exercise, we'll assume his observations appear in the trends table, cells J7 to P29. J7 down to P29. The values in the column titled Y, cells M29 to cell M9, represent annual economic output per French subject, which we will call average income, since national income and output are roughly equivalent. Each row of the column titled I implies the loanable funds market is in equilibrium. Loanable funds supplied by savers equal loanable funds demanded by borrowers. Because savers supply funds in exchange for interest and investors borrow them by paying interest, total savings equal total investment. Like output, those values and the ones in the column titled C, consumer spending, are also expressed in average terms. The light gray rows, cells J9 to P17, record past data that's already been observed. The dark green row, year 9, shows the present, and the light green rows, cells J19 through P29, display Turgot's projections for the future, assuming no changes to the parameters in the worksheet's top left table. These we're going to hold constant. In year 0, the economy combined 1,212 units of labor and 409 units of capital to generate economic output in the amount of 200.381 livre, which is right there, per French subject, with 180.342 livre used to purchase consumer goods and services, and 20.038 livre set aside as savings. With the savings rate of 10% from year 0 to year 8, capital decreased to what? So capital starts at 409. By year 8, it's barely lower than 409. It has decreased to 407.591. Output rose from 200.381 to 204.887 livre per French subject. Savings increased a little bit from 20.038 to 20.489. Consumer expenditures increased from 180.342 to 184.398. We're going to convert the above 8-year changes into average annual growth rates below by using unrounded values in the calculations, dividing each total percentage change by 8, and then we'll report the final results using two decimal places. We need capital. Capital is in column L, right? Equal parenthesis. I'm going to come up here and get capital in year 8. I'm going to subtract off capital in year 0. Then I'm going to divide by the capital in year 0. To convert it to a percent, I'll multiply that by 100. And you can see it here in this box. 407.591 is what capital is in year 8. 409 is what it was in year 0. So it is the blue number. It was the red number. That difference divided by what it was, this red number. We're going to multiply that by 100 to convert it to a percent, but we also have to divide it by 8 because we have 8 years here. And we get an average annual rate of really close to 0. Capital lowered by 0.043%. We only need two decimal places, so 0.04. I don't need the negative sign because it says lowered there. I'm going to press enter to make sure I got it right, and I do. Now, what about output? So since we're calculating the percent changes, I can just drag this across. Then I'll double click on it and make sure it's done correctly. So I have what output is in year 8 minus what it was in year 0 divided by what it was in year 0 with parentheses around this difference. Multiplying it by 100 to convert it into a percent and then dividing by 8 because this is an 8-year rate. We want it in per year terms. Output increased by 0.281%. I had to change it to 0.28 from 0.281 because it's asking for two decimals. Let me just drag this across to get the rest of them. Savings is the final one down here in column P. It increased by 0.28% as well. And then consumer expenditures, that's in column O. So this is what consumption is in year 8. This is what it was. We're going to divide that difference by what it was, multiply that by 100 to convert it into a percent. Then we're divided by 8 to turn an 8-year percent change into an annual percent change. So this equals 0.281 as well. We'll report it in two decimal places instead of 3. And I'll press enter to make sure I got them right. Now, suppose the savings rate and the other parameters are not expected to change. Using unrounded values in the calculations and rounding the final results to two decimal places. What I'm going to do is I'm going to drag this down, then I'm going to double click it. This is what capital is in year 9. This is what capital was in year 8. So I'm going to take this difference with parentheses around it, and I'm going to divide it by what it was in year 8. Then I'm going to multiply that by 100, and because this is a 1-year period, I don't need to divide that by 8. Then I'm just going to hit enter, and I'll drag it across. I'll make these all two decimal places down here. Then I'll enter them into the boxes. Capital increased 0.3%, almost 0. Output climbed 0.31%. Savings rose 0.31. And consumer expenditure grew the same amount, 0.31. Then I'll press enter. For the following growth rates from year 9 to year 20, divide total growth by 11. So now I'm going to drag this down. I need to move this blue box down to year 20. This is what capital will be in year 20. This is what it was in year 9. And again, these are projected values. What we expect it to be in year 20, if everything remains constant, minus what we expect it to be in year 9, a year from now, dividing that difference by what we expect it to be in a year, multiplying by 100 to convert it to a percentage, but this is an 11-year period of time, so we have to divide this percent change by 11. And then we can drag it across. Percentage increases are really close to 0 again. We have 0.11 for capital, 0.36 for output, savings, and consumption. And I'll press enter to make sure I got those right. In reflections, Turgot argued that all lending comes from prior savings, as individuals set aside a portion of their income rather than consume it. When the savings rate is 10%, output didn't really change all that much over this long period of time. Neither did consumption, neither did capital, neither did investment or savings. Guided by individuals' needs, habits, and time preferences, this setting aside of funds creates a pool of savings independent of the interest rate. This idea is reflected in the loanable funds graph, where the supply of loanable funds is perfectly inelastic, a vertical line. The interest rate is determined at the point where this supply intersects downward sloping loanable funds demand, which represents entrepreneurs' willingness to pay based on the profits of capital employed in enterprises. Today, that is referred to as marginal productivity of capital, or MPK, plus a premium for waiting, the advantage of enjoying a thing in the present rather than the future, which we call time preference rho. In his words, interest arises from the profits which capital can procure and the compensation due to those who consent to deprive themselves of the present use of their funds, which would be expressed today as the marginal productivity of capital plus rho, which is time preference. Using the values in the trends data table and the loanable funds graph, analyze the loanable funds equilibrium in years 8 and 9. I'll let you figure out the answers to this and that. Now, if you get it incorrect and you're not sure what to pick, come to my office hours and we'll discuss it so you can get the correct answer. In year 8, the market interest rate and the amount of loanable funds were what? If I click on this point right here, it looks like 20.55 and 6.45%. We'll go over here and double check, make sure we got it right. Savings in year 8 is 20.489. And the interest rate in the loanable funds market would be the marginal productivity of capital plus the person's time preference. And the marginal product of capital is 0.025. We got to add to that the time preference, and the time preference is 0.040. That's 4%. We're going to add that 4% to 2.5%, and we get 6.5%, which is pretty close to this green point. The black point is behind it. The green point is for the year 9. The black point is behind it. It is for the year 8. We'll press enter on this to make sure we got it right. I got it marked wrong because what we need to do first is we need to convert this to a percent. I'll come up here and turn that into a percent and add a couple decimal places. So we got 4.00%. And then I'll do the same thing over here for marginal productivity of capital. We'll change those to percentages and then add a couple decimal places. In year 8, we have 2.45% plus 4%. So this should actually be 6.45%. And we'll press enter. We should get it correct. By year 9, with no changes in the savings rate or other parameters, the market rate will still be 6.45%. The quantity looks like it's 20.55, which is a change, small change. Let's go over to our table here to verify. So again, our time preference hasn't changed. We got 4% plus 2.45% in year 8, 4% plus 2.45% in year 9. But it does look like the amount of money we're saving went from 20.489 to 20.553. So it changed just a little bit. So the interest rate remained at 6.45%, and the amount saved increased to 20.553. Turgot regarded saving as a purposeful decision to defer immediate consumption, directing resources toward capital accumulation, the engine of economic growth. By investing in productive tools and infrastructure, savings enhance future output. This perspective may reflect his early religious education. Remember, in 1750, he chose not to take holy orders, given the trajectory his career was on and the education he had gained. He understood the Bible very well because he studied it probably every day, all of his early life. So that early education most definitely informed his economic theories. His religious education, I suspect, emphasized restraint through commandments against coveting, which discourages consumption-driven debt. And then there's the principle of sowing for future rewards. I can see him using this religious training he got to inform his economics. Don't covet, because if you covet, you'll want to consume. If you're consuming, you're not saving. If you're not saving, you're not sowing. And in order to grow wealth, you have to sow. Perhaps after discarding his religious career, he maintained these lessons as metaphors for investment. So for Turgot, economic prosperity hinges on a virtuous cycle of savings and reinvestment, prioritizing internal capital formation over external factors like trade. To boost the savings rate, which of the following policies would Turgot likely lobby King Louis to enact? Again, I'll let you pick the correct one. If you get it marked wrong, don't guess. If you're not sure which one's the correct one after you get your first attempt marked incorrect, come to my office hours. We'll discuss it so you get 100%. Suppose the king enacts a law on the last day of the year, and that law increases the savings rate to 20% in year 9. We're going to recalculate the growth rates from year 8 to 9, assuming all of the parameters remain unchanged, using unrounded values for calculations and rounding all final results to 2 decimal places. Now we're going to change the savings rate. We're going to increase the savings rate from 10 to 20% and observe what happens. Consumption drops substantially. The person was saving 10% of their income. Now they're saving 20% of their income, which means if they're saving a huge portion of their income in year 9, then their consumption is going to fall off quite a bit in year 9. But look what happens to capital accumulation. Capital accumulation accelerates. It was pretty flat, but now it's on this upward trajectory. Because people are saving more, there's more money available for lending. Borrowers can borrow more to buy new equipment, expand current factories, or invest in technology that makes them more productive. So this drop in consumption is beneficial for capital accumulation, and there's no drop off in output. Why? Well, the person buying consumer goods stopped buying consumer goods, but what has the entrepreneur done? With the increase in the supply of loanable funds that has happened from black to green, loanable funds pool went from 20.49 to 41.23 because of this increase in savings. That additional money saved gets lent out. Who borrows that additional money? Entrepreneurs. And what do entrepreneurs do? They buy capital goods, ovens from oven makers, bricks from brick makers. Although consumer good and services purchases have dropped off, intermediate goods, goods that are used in the production of consumer goods, increases. So the economy is just shifting from consumer goods to intermediate goods, and intermediate goods are the goods that are used in the production of consumer goods. Consumers are buying less, entrepreneurs needing to expand their operations are buying more. They are buying more bread ovens, bricks, grinding mills, sawmills. So you don't see a decrease in output. In fact, output accelerates. And you see down here with the boost in savings, this shift from the gray point to the green point is the difference in the amount that is invested. This jump here is the same as this jump. But now look at investment. It's accelerating, whereas it was pretty constant before. Now it's accelerating. Why? Because eventually, even though consumption drops off the cliff, eventually consumer spending exceeds what it would have been had the savings rate remained at 10%. So that leads to even more capital accumulation and more savings and higher increases in output. What happens to capital? We'll do it from 8 to 9. You have this big jump in investment from 20.489 to 41.229. You have a huge drop in consumer spending from 184.398 to 164.915. You have this drop in the marginal productivity of capital from 2.45% to 1.42%. You have an increase in GDP. You have a small increase in capital accumulation and no change in labor. So these percent changes down here, delete this row. We're going to use these as the percent changes from year 8 to 9 when savings goes from 10% to 20%. So capital increases by 0.03%. Doesn't change too much in that first year. Output increases a little bit from year 8 to year 9 when the savings rate goes from 10 to 20%. Savings rises dramatically by 101.23%. And consumer expenditures decrease by 10.57%. Now we're going to recalculate the growth rates from year 9 to year 20, dividing each by 11 to account for the period's length, assuming all other parameters remain unchanged, using unrounded values for calculations and rounding final values to decimal places. The savings rate changed from 10 to 20. So for all these numbers in green, it reflects a savings rate of 20%. This represents percent increase from year 9 to year 20 with that increase in savings. 20%. In year 9, we expect it to be 104.7. In year 20, we expect it to be 649.195. We take that difference, we divide that by what it was in year 9. We multiply it by 100 to turn it into a percent. And then we divide it by 11 because it's an 11-year period, and we want the average growth rate on an annual basis. Capital is expected to increase 5.38% per year over the next 11 years. Output is expected to increase 3.16% per year over the next 11 years. Savings is expected to increase 3.16% per year over the next 11 years. And so too is consumer expenditures, 3.16%. Using the values in the trends data table and the loanable funds graph, analyze the loanable funds equilibrium in years 8 and 9 after the savings rate increases from 10% to 20%. So let's go over to the loanable funds market in the simulation. So in the loanable funds market, savings equals investment, or the amount that is borrowed. I'm going to let you pick the correct answer here and here. Demand went from black to green. In year 8, the market interest rate and the loanable funds were what? Well, in year 8, total invested was around 20.49, but we need 3 decimal places. The interest rate, which is fine at 2 decimal places, is 6.45%. So the interest rate in year 8 is 6.45%. And the amount of loanable funds was 20.489 livra. By year 9, we expect the amount of loanable funds to increase to 41.229. The interest rate fell. We're keeping the time preference parameter at 4%, but the marginal productivity of capital went from 2.45% down to 1.42%. So the interest rate fell to 5.42%. We'll go to our graph here just to double check to make sure these look reasonable. So this is year 9. We expect the interest rate to fall to 5.42% and investment to rise to 41.229. This rounds it to 2 decimal places, right? We need 3. After the new law raises the savings rate to 20%, annual consumer expenditures, the green line on the consumption graph on the left side of the Excel simulation, they fall below what they would have been if the savings rate had remained at 10%. By what year does actual consumer expenditures surpass what they would have been without the increase in savings rate? Because there's a huge increase in savings from 10% to 20%, consumption falls. But at some point in the future, consumption at 20% savings exceeds what consumption would have been at 10% savings. I think the news media would report this as bad news today, pressuring politicians to repeal the law that resulted in the savings rate rising from 10% to 20%. Because politicians need to worry about getting elected next year. So let's look at consumption. This is consumption on the previous trend, and this is consumption on the new trend. In year 13, consumption is expected to be 185.65. It would have been 187 had the savings rate remained at 10%. In the 14th year, had the savings rate remained at 10%, consumption would have been 188.09. But up here in year 14, with a 20% savings rate, we're at 190.853. By year 14, consumer expenditures surpassed what they would have been had the savings rate stayed at 10%. Turgot viewed saving as a strategic choice that fuels capital accumulation, the engine of economic growth, by channeling resources into productive tools and infrastructure that enhance future output. Metaphorically, this is the sowing that Turgot learned about in his studies of the New and Old Testament. This process highlights the paradox of saving. Although households temporarily consume less, their deferred spending enables greater investment in capital, which in turn raises productivity and output. Over time, this higher level of economic growth leads not only to more goods and services being produced, but also to higher levels of consumption than would have been possible if people had continued consuming at the lower savings rate. In this way, Turgot's insights show how sacrifice in the short run can generate prosperity in the long run.